Hi, good morning. Okay, welcome to the API, all things API session 2. Actually, we got delayed by 15 minutes due to some technical issues, and Google Hangout could not recognize my internal mic, so I was actually muted. So, unfortunately, I couldn't start this broadcast by 8 a.m. And also, I have invited few of the guys, so I'm not sure whether they joined in the old broadcast and couldn't find it and hang out. So I have created this new broadcast, given them the link. Hopefully, they will find it and they will join. I hope so. Also, this is the date is 1st of July 2018, 8:15 a.m. So it's a Sunday morning, so people will be able to join as early as this in terms of Sunday morning. Nevertheless, let's look at some of the areas which I promised I will talk about in this session. And meanwhile, if the guys join, then it's a great bonus. So let's quickly start our subject. So when I was thinking that I will talk about this point, there are no microservices. I wanted to dig deep into this session, and I was inviting some of the like-minded people who can come and contribute towards this subject. No microservices. So there is only microservice architecture, but there are no microservices as such. So this is the point I wanted to bring up. So I'm going to show you one PDF, okay, or some kind of diagrams. It's not created by me. I'm going to give credit to a gentleman who actually shared this PDF, and my intention is to discuss this PDF. Okay, so what he would have meant and all that. Okay, that's a kind of thinking. Okay, so I'm going to share the screen, and let's dig deep into this particular material. Okay, this material not created by me. This material is created by somebody else, but I'm just sharing it so that it's a this material is in the cloud. I'm not violating their IP and all, but all I'm doing is this is a similar topic I wanted to talk to you. Material is already there in the cloud or in the web, so I might as well show you, give the credit to the gentleman who created, and start discussing that. Okay, as it, but there is angle session, but that's different. So let's do this. Okay, so let me see how can I share my screen share. Okay. Just give me a minute, please. I don't know how do I share this an application, but nevertheless find this. Okay, so let me share it. Okay, guys. So this is the um, PPT which I wanted to show you. Okay, so this is created by Chris Richardson, founder of evantuate.io, founder of cloudfoundry.com, author of Pujos in Action. Okay, so this is his material. Okay, so just and you can reach him chrisrichardson.net. So now this is a very useful PPT. I think you have used this to present something. So let's dig deeper into this and then talk about it. Okay. Right now, first, what is okay? This is interesting. So architecture equal to elements, relations, and properties. Okay, or I like this architecture equal to boxes and lines. So architecture, either it is monolithic architecture or microservices architecture, irrespective of that. Okay, so what we will see is when an architect come and present the system or application architecture, you will be seeing lots of boxes, color coded boxes, and the lines going from one to another. Okay, so that's typical architecture diagrams you'll see. It can be an infrastructure architecture, or it can be a data architecture, or it can be business process architecture, or it can be an application architecture, irrespective of the area. But as an architecture, if you see any architecture, if you see, or is a building architecture, it will be boxes, and then connections. Yeah, and so that is what this architecture is all about. Right now, so that when you say that connections can be, what are the systems talking to what systems, what are the systems integrating with what systems. When you talk about data architecture, what are the data entities are related to other entities. When you talk about infrastructure architecture, what IT estate is talking to, or IT server is talking to what server, what kind of security is going to be, things like that. Okay, so as I was telling you, multiple views of an architecture, a same architecture can be seen from an application, can be seen from a business, can be seen from a data, can be seen from an infrastructure. So you can do multi view. Okay, um, yeah. Right now, coming, so he is saying that the views can be a logical view, like as I was telling, this can be a kind of order and restaurants, the entities can, how each entity is going to relate to each other. Um, in this example, he has given a consumer's orders, and an order is placed in a restaurant. It can be for applications like Just Eat, where a consumer is an app or a website, and order is their order management system, and restaurants who are the key stakeholders or entities receiving the orders, fulfilling the orders, delivering the orders, updating the status of the order. Right. So this is the way of logical view of Just Eat, if I may say. Right. Then coming into implementation view. Okay, now, so this is two entities, processes, order management process can talk, or system can talk to um, consumer, system can talk to restaurant management. So as I was telling you, that these are all the various applications that talks to each other. Okay. Now let's move into this layered architectural style. You have a multi-layer architecture. For example, the lowest will be usually the data layer, Okay, the middle part will be an application layer, or then you have a business layer, then you have a presentation layer, then you have the actual end users. That's a typical way you will segregate, isn't it? So presentation layers are nothing but user interfaces. It's in the topmost layer, sitting and actually integrating with the application. So that will be the presentation layer. Then you have application layer. So application layer or a service layer, which actually exposes all the application features in a service. Then you have a business layer where all the business rules are managed. Then you have a data layer where all the data is stored. So it's the various layers you can talk about. So architecture captures functional requirements and non-functional requirements. That's very true, isn't it? Because um, when you when you design an architecture, and when that gets into the reality, it meets certain requirements, and the requirements has to be both business requirements and non-business requirements, basically. So this is all the abilities an application or architecture is to provide. Okay, so this is you have maintainability. So an architecture needs to be maintainable. Maintainable in the sense, okay, so that's very interesting. Well, let's see what is maintainable is all about. Let me go to. I want to. Let me stop sharing for now, or stop screen sharing for now. Okay, so maintainable is basically one second. Let me just close unwanted windows. Right. So maintainability is all about okay, how do I actually support this particular application, right? So that is maintainability. So you create certain application, whether it is monolithic or it can be microservices architecture. It's not about the fun in development and getting a sense of achievement that I have done this microservices architecture. So it's all about whether that meets your demands, right? Whether it meets your requirements. That is as part of the project. You will prove that meets the requirements, and also after the project is done, dusted. Yeah, when you go into the next phase, which is the BAU, operational stage, is it maintainable? Is it is getting difficult in making the changes, right, and rolling out the changes? So that is what is maintainable. It then deployable, how easy to make changes, how easy to make to deploy the change so that the changes are reflected. There are too many dependencies. Does it require a lot of downtime, or can it be deployed on its own, and then if some kind of connection can be provided so that you can easily make that there used, basically. So that is another way of thinking about deployability and testability. So how easy it is to test. Does it going to be taking a lot of effort to test it? Do you need special tools to test it? Do you need a complete set of integrated environments to be testing it? So do we need special tools to test it? Things like that. So next is security. So how secure your application is, how secure your architecture is, whether it integrates with your identity and access management, or it integrates with your Active Directory or LDAP. So all these security softwares, where you store your groups, you store your roles, you store your access privileges, definitions of it, can this application hook into that and make use of the same, or is it going to get duplicated? You know, so that's something. Reliability, how stable it is, in terms of um, during a peak time, is it actually working? Is it stable? Is it actually going down very often, or is it stable? Reliable is also during some kind of error scenarios. What kind of information you are capturing in terms of error? Is it helping the support team to triage it? Then is it auto recovery, error auto recovery? So things like that are comes very subtly. Then you have what is called as scalable. So scalability, it can be in terms of transaction management. If it is peak load, is it scalable? It can I add extra servers, extra memory, extra processors to this whole application so that it can scale up during the peak time. For example, Christmas time, e-commerce application will be up to peak. So can I add extra processing power to it and make it scalable? So does your architecture and application supports this way? Is the way your IT infrastructure has been designed for this application? So that's something you need to look into. And also scalability in terms of uh, making changes. So can I add features easily? So that is more of a application scalability, feature scalability. So you need to look at. So if you have created certain things, like let's take e-commerce as an application again. So you have created a kind of a catalog based application. So your catalog is comes. You have ability to add it to the cart. You have an ability to add checkout. You have ability to collect payment, and you have ability to track the order. So this is a very basic e-commerce functionality. Okay. Now the business wants to add an extra functionality like uh, doing some kind of promotional vouchers. So at the time of checkout, if you have to do add some voucher codes and the discounts are applied. Okay, it's a very common feature in e-commerce, right? And that's why a lot of voucher websites are there. So to make that changes, do I have to redesign my whole e-com application? Is do I have to redesign my complete checkout process? So things like this comes in terms of and feature scalability. So that's your the way you've designed and architected your solution. Does it actually help you here? Okay, there are various features. There are various key important items you need to remember when you actually design your architecture. Okay, so now next thing is route to market, right? Route to market or time to market, that's very important. How fast you are actually putting things into life. So that is a very key important factor. Do you take lot of time to promote your change? So that's another important aspect you need to look at. Okay, so now let's look at this in terms of your application. So this is, I'm going to share the screen again, and I wanted to see whether okay. Okay, I think I have never stopped the screen. That's fine. So you can. I hope you can see this. Um, Successful applications keep growing. So do you see this whole thing? So so this application is identified in the yellow. Sorry, blue. Apologies. Not. I'm not color blinded. The blue box and then a green box defines the application team. So as time move on, you have a stable application team in terms of numbers, but your application keep on growing and growing and growing. It becomes unmanageable, right? Then you split teams into, you split multiple teams. Like there are experience in me where you start with one team and then you end up in multiple teams. For example, you have a UI team, you have a database team, and you have an army of people for web services team or integration team, and you have a business analyst team, but your application is so all these kind of, let's look at all the kind of legacy banks, right? So this banks, what do they have is they have one big application, but you have 1,000 teams to support it, right? To make changes to it. So that is what is that's what is going to cause when you start making changes in this application where multiple teams are involved. How do you coordinate with all these teams, and how do you promote changes easily? So that's why banks, if you see, they actually um, keep release teams um, as a dedicated function. So release teams, change teams, or dedicated functions, I would say. So why do we actually need the release teams and change teams? Because the changes are becoming very complicated with in terms of one small change impacting all the other applications. So people needs to be very very careful, because I'm not blaming them. It's very important function, if I may say so. Change team and release team, in the view of the current way of doing things, they play a key role in terms of coordinating, in terms of managing a release. A release is actually, if you actually put in you, it's a kind of big bucket where you everybody will come and puts their own contribution in terms of changes, and the release team has things lined up in a particular order, so that one is not conflicting with the other. And also, when you deliver this bucket in a pile of things you already got, that's something not get broken. And when this in this bucket of changes is tested along, it will be tested again. They call it as a release regression. When you test it again and then test it, this changes against everything else needs to stack. Okay, so usually it will. So that's the kind of funda in terms of release management. Change management, change one column edit, you need to make they need to see, okay, what are all the applications is impacting, and how we can make sure that this change not affect the others. So that's a kind of change management. And you have a CAB, change authority board. They come in every period they agreed. For example, every month they come and then understand the kind of changes and then approve or reject whatever they want to do. Okay, so that's the kind of funda. Okay, so this is why. So these are the key challenges, right? So this is when the new things started come out. For example, agile teams started coming out. So multiple teams working on a big application. The time to market was a big trouble. So they started doing changes in a small chunks every 2 weeks, and then would start delivering it. So that's bless me. Okay, that's new thing that came out. Then scaled agile came out, best because one team working with one small application, agile and scrum all works good. But if it is a complex program where they want to move into agile fashion, this kind of a silo agiles, most of the banks or So I call it a silo agiles. That's not going to work out, because you might be turning out your changes, but you go at the end of the day, you go stuck in the queue, and then it all gets delayed, and that's the way it is. Okay, because that's the way the requirements are gathered, that's the way the whole thing gets tested, that's the way the whole thing gets impact analyzed, that's the way it's going to be released, right? So just we have to accept that fact. But things are changing, so that's why they call it as a scaled agile. The whole stack is getting agile. Okay, and DevOps came in picture, in terms of making sure the culture is there, in terms of collaboration, in terms of continuous knowledge transfer, in terms of trust. So all that are DevOps culture, and the teams are now co-located in terms of development and operations, and business teams are all co-located, and they understand the changes, they understand requirements together, they make the changes, they test the changes, and they support the changes, or they put the changes into life. So these are the key DevOps principles came in picture. Okay, so even then things are improving, people are making efforts to make changes, but that's where the whole micro monolithic architecture comes in your way and blocks it, right? So because a whole big application, a banking application, um, the whole fund of fastness, the whole fund of scalability, the whole fund of reliability and all that, that's now questionable, because of complexity of this whole stack, and trouble in making those changes in the fastness people are expecting us to make the change. And so that's the kind of challenge that's happening in this whole monolithic architecture. Okay, so how do I actually do this? Then you call it as okay, microservices. So this is when the whole microservices come into picture, where I wanted to go microservices. There's nothing called microservices, there's only architectural styles. So that's why I termed this whole session idea called there's no such thing called microservices, there's only microservices architecture. Okay, so architecture, as I was showing you from Chris PDF, architecture is boxes and lines. It's the way of presenting the details of an application or a business or a data. So it defines the relationships and all that, right? So that's the whole fund of microservices architecture, not microservices as a term. Okay, so now just want to see whether I can show you something here. Okay, right. I think this is a really useful slide. I'm going to share the screen again, and you can see this now. Right. Okay. So now can you? I hope you can see this, right? So service is equal to business capability. So for example, SOVA. So this is SOVA slide basically, I think. So where you want to create a service that actually defines your business area domain. So if you go and if you would have heard my session 1, so I would have told about SOVA is actually if you take every business functions and you actually create a service out of it. So this department as a service, right? So for example, every business functions, my order taking is a function, delivery is a function, inventory is a function. So every department, every systems, every sub domains create their own services which actually exposes their functionalities, right? but all are still hosted in an application. So you don't get me wrong, by exposing that as a function or a service, you are not breaking away from your whole monolithic nature. It's all hosted in a single server, it's all talking to single database. So there is no way of scaling each function on its own. And also supportability, there is no way of putting additional supportability feed capability for each functions. So it is for all or none. That's the way the whole application are stacked basically. Okay, I hope you understand this. Now, okay, so now microservices, as this is what I was telling you. Okay, there's no such thing called microservice, because there's always micro architecture. Microservice is architecture, not a term itself. Okay, so this is a kind of a good example Chris has put in. So this is an example of a microservice architecture as such. Again, this is for, let's say, Just Eat possibly. So you have UI. So UI is represented in the left, and UIs can be apps. UIs can be browser. UIs can be an actual system. UIs can be telephone. UIs can be anything. Okay, so that is what is a presentation layer is managed. Then you have what is called as a service layer. A service layer is again um, exposing each function as a service or a API layer. So API layer is application programmable interface, is a piece of code, is a piece of interface where you actually share your business data to the UI or to any other third party using that funder. Okay, so and you host that APIs in a particular gateway. As a gateway is as I was telling you, so gateway is a place where you actually expose yourself to the outside world. Okay, so every country has their own gateway memorial where the people it's a kind of olden tradition where invaders have come in, or invaders have gone out from that point. So it's a kind of a gateway, it's a symbol where they say this is the entry point to my country. Okay, similarly currently in today's world, all gateways your immigration uh, officers and immigration systems are your gateway to a country. Either you come in, you actually get your visas validated, and then you come in, right? And you go out, you get your stamped in your passport, and you go out. So that's just the kind of gateway, if I may say that. Now another thing is then you have APIs. As you can see, the APIs are your catalog API, you have a order API, or you have review API, and you have a backend, which is your catalog database, your review database, your order databases. So this is the whole structure of the microservices. It's an example to the microservices. Okay, so but again, very interesting point here. So here also, hello, hello, hello. Somebody joined. Hello, hello. So Raghu, are you joined? Hello. Okay, fine. So let's move on into this. So now let's look at all the abilities, okay, which we were talking about. Okay, for example, you have maintainability. Yeah. So if there are teams, operation teams who are actually maintaining this whole application, you can have, if for example order is your key area, so your whole business is based of order, and review is a bit of less priority for you. So what you can do is you can actually add your capability into order, in terms of maintaining your application. You can actually add extra people or extra monitoring systems on order than review. Okay, so that you can do. And in terms of scalability, usually what they do is they actually host this order database in a separate infrastructure usually. And by during peak times, using the cloud infrastructure model, they can actually add extra capabilities to that server in that particular order module or order management system. Now, order management system is order APIs and order database and order business layer is forms your order management system, nothing else. When you come to review, for review department, you have review APIs, you have review business rules, and you have review database on its own. That forms your review management system. Catalog similarly. Okay, all independent pieces of softwares hosted separately, and one not impacting other in terms of the infrastructure, in terms of your data. So this is when this a kind of, there will be some interesting things you need to know. It's called something around data duplication or lack of data integrity might be there in some cases, because completely different databases, right? So sometimes you might have to duplicate the order items into your order management system, instead of just referencing the catalog items. So the kind of normalization will be a big something you need to look at in this old in this old microservice architecture. So I'm just going to again ask Raghu. Raghu, are you there?
Hi,
Hi,
you can
Raghu.
join. Yeah.
Hi, Raghu. Hi. Okay, Raghu. So I was talking about this whole microservices side. Since you're
Yeah.
okay, so this you are the one guy who came in and joined this group up. Thanks for your time today. Actually, we have around another 10-15 minutes. So I like to know from you, because this is all about discussion, not just me talking in a monologue. So your views are very important. If you have experience around this area, um, what's your experience around APIs, and what's your experience about around monolithic applications, and what kind of challenges you think you actually facing or faced in the monolithic application, and what are the things, if at all, you within your capability, in your skill set, or within your environment trying to do something on that side. So that's this is some kind of, possibly I would like to dedicate the next 10 minutes for you to come and share to the group. Whoever sees this video, it's going to be hosted in YouTube, so anybody will come and see this. So if you could, if you think you can share something, it will be very useful. And next 10 minutes you can talk about it, and we can have a good kind of discussion rather than me going through this and explaining all. Yeah. If you want to share anything, please.
Yeah, sure. Thank I think I'm having other headphones.
Yeah, Raghu.
I think there is a echo.
Yeah, I think it's an echo. Yeah. Um, Wait, I will try to do one thing. So
So maybe someone is on a speaker.
Possibly me.
Oh.
Can you do this? Can you, hello?
Yeah. Now it is better, Prem.
Hello?
Yeah, Prem, I can hear you.
Yeah, carry on. I think now it's better, I believe.
Yeah. Yeah. First, thanks, Prem. Thanks for taking up the session, and sorry for joining late. I just saw the message actually. Just went out and yesterday I could not log in, so just saw the message very late. But I thought,
That's okay.
yeah. Okay, coming to my experience, I'm mainly into the integration space, working in integration as an integration architect from past 5 6 years. Um, and In integration, I have worked on multiple products like Oracle, Middleware, MuleSoft, um, um, TIPCO to some extent. But right now I'm focusing on MuleSoft API and MuleSoft Service Bus. Um, and Mainly the reason why I wanted to share something or maybe learn something from this session is uh, what are the triggering factors mainly to move from a server based applications to a microservice applications. People are nowadays people are very much interested in moving to microservices. But honestly, I don't have much experience on microservices, but I have very good understanding of what microservice is. But uh, but what is the triggering point to move to microservices? And for example, I have built hundreds of APIs or thousands of APIs in some using some tools and some products. What is the need to move to the microservice application? Uh, what are the extra benefits that we get moving there? So I want to basically understand these points.
Yeah, I think very good. Like, is it APIs is what is microservices? So it's a very good point you actually brought into this forum, because um, is APIs equal to microservices? That's the whole kind of
No,
discussion that nowadays happening. With microservices are becoming much more and more famous, and everybody talking about it.
no,
I'm not sure you are from India, or you live in India now, or you are in UK or in US. I'm not sure about where you live actually. Um, the reason is, in UK, this whole funda is becoming much more evident now, because of some of the banks are actually now going for APIs and open banking and API economy. So this is the kind of way the whole industry is going in terms of banks. So I work in a banking sector, so I know that. So that's why I'm saying this. Similarly,
mm,
there are health industries are going into that whole funda in terms of smart health systems and all that. Similarly, utility companies like LNG providers are moving into smart meters. So that's another big drive is happening in UK. At least I know for UK basically. So that's another area where they are doing it. And with all this with all this Alexa and all this Google, all this new set of home assistants coming in, they're going to take over our day-to-day operations and then interact with other systems and get the job done for you, you know. So so providing APIs, does it actually mean that you are into microservices? So that's the kind of question that's happening. So so this whole forum intention for people like you, people like me, can learn from each other and bring something to the table. So my views of this whole funda is, why do I need to go into microservices architecture, though I can create APIs in my current setup and provide APIs to the third world or third
mm,
parties? what is the need for me to moving into the microservices architecture? So that's the whole kind of question, if I have summarized it correctly, right?
Yeah, yeah,
Yeah. So number one, the speed of delivery, that's one thing. um, this whole monolithic applications, I'm not sure about your experience, but when I if I look at my experience, there are banks who have big applications which are, each of them are tightly coupled so much that nobody knows now what is talking to what. Okay. And nobody knows now, if I change this data item, what other system, what other reports, where and all is going to be having an impact. Nobody knows it. So that's one of the big challenge around making changes in the current applications we have got. So once the moment nobody knows, things will get slowed down, because they don't want to do changes in an hurry and break their whole application. So they want to take it slow, when they and do a proper impact analysis, and then promote the changes, right? So that actually impacts your time to market, number one. Number two, it is costly, because you need people in various areas to provide you inputs to know what are the changes you need to make a certain thing. There are many areas where you need to make some changes because of this impacts. You need to test everything. There's something called, with my experience, there's something called release regression, and all those testing needs to happen before you put a small change into live. Okay, so a lot of people needed to do all this stuff. And also, the way they have hosted the whole application, they host it in one server, uh, and if that server goes down, the whole application goes down. Okay, so that's another area. And that server hosts multiple features for a bank or any company, where some features are more critical than other features. Like I was talking in this section, like let's take a restaurant system, okay, or apps like Just Eat, where you have order management system is critical than review system. Okay, order management system is the breadwinner, right? It's going to make the money for them. People placing order in Just Eat is making money than the people reviewing the restaurants. Okay, so that in just it's all reviews also important, but orders are more important. Okay, similarly, when you take e-commerce, you getting order is the breadwinner, rather than recommending them some other related products. So why I'm saying that is, everything hosted in the same environment, all these applications APIs share the same resources, share the same memory, share the same CPU power. So if there are 100 people reviewing an app, reviewing a restaurant, and if there are 50 people putting orders into that app, this review application, which is very less importance for this whole app, because review is not generating the money, order is generating the money. So order system becoming slow now, because many people are involved in review, so that APIs is consuming lot of memory rather than your or order systems. So this is all kind of funda. Um, it's it's uh, it's it's a kind of drawbacks in this monolithic. This, see, whatever I spoke, it's nothing related to APIs. It's all related to um, some of the challenges having a monolithic application. Okay. Now, alternative is microservices or microservices architecture. That's what the whole session agenda is. There's nothing called microservices. There's only microservices architecture. That is not APIs. That is your architectural style in the way you segregate each business function as an API, as a every business function has their own server, have their own API, have their own business rule, have their own database. Okay, and the interfacing of that is through APIs. So multiple systems talking to each other or only through APIs, and they're all hosted separately. When they are hosted separately, you can easily add extra memory, extra processing power to a function which is more business critical than a non-business critical one. So you can scale up your infrastructure for that function very easily, faster with all the AWS, Google Cloud, and Azure and all the stuff. And making one change in review management system, you don't need to worry about what is going to happen in order management system. Or making a change in order management system, you don't need to worry about what will happen in the review management system, because system A and system B is not tightly coupled. It's all integrated through APIs. As long as you keep the API interface common, agreed, contract is agreed, whatever you make changes downline, other people are not impacted. It's loosely coupled. So things like this are the advantages of moving into microservices architecture. So that's my view. What do you think about it, Raghu? Are you
Yeah,
there? Sorry.
yeah, yes, yes, yeah, yeah. Completely agree with you, Prem. Um,
So
Microservices, yeah, you said right. It's a basically splitting up the big functionalities into many functionalities, and
correct.
so that we have more control over that. We can manage that easily. Um, and in the when we are in agile world, right? So we can have a many deployments on a particular day if you
Yeah.
go with the microservices architecture plus containerization of the applications.
Exactly.
Uh,
Exactly. Yeah. That's
yeah,
that's that's all.
and
But how
yeah,
easy it is to go into that mode? So that is the another interesting question.
yes, yes.
That will need a separate session. Possibly, I will schedule another one to talk about how easy is to migrate from current way of doing things to microservices architecture. So, what you if it is a greenfield project, if it's a new project, it should be easy, but because you design from the beginning. But are you working in a greenfield project, or you are working in some kind of an what's the kind of project nature?
Right now, I'm working in the greenfield, but not on the microservices architecture. But we are designing and developing some APIs using MuleSoft to integrate some of the applications
Okay.
in the client architecture landscape.
Okay, okay, that's interesting actually, because so with my experience working in banks and all, it's going to take, and I don't think it will ever happen. Banks moving into microservices architecture because they've got so much technical depth with them, and their applications are so complex, and so many years of experience have gone into that. It's never easy to move into that and that style, and also it's going to be costing them too much money. So I'm completely confident that they won't move completely into Microsoft, but wherever possible they will look into that. That's my view. um, so How easy is to do your APIs in your MuleSoft tools?
Yeah, API management. I mean, nowadays a lot of tools provide that capabilities, that functionalities. We have many tools like MuleSoft, APG, Layer 7. There are many tools which are available. And the main advantage of these tools is we can create and manage the APIs. And that, as I said, that the time to market is quick.
Mm,
Uh, and the management and monitoring and the governance of these APIs is right.
mm.
So that becomes very easy when we're
Okay.
using these tools. So
Governance of APIs. So that's another
yeah.
interesting area because um, uh, do you have strict governance around these APIs? How do you name the APIs? Whether the interface is
Mm.
adhering to the standards? Is there any kind of tight governance, or you can do whatever you want in terms of API definitions?
Mm. The governance can be two types, right? It can be a design time, it can be a runtime governance.
Correct.
Uh,
Let's talk about design time
yeah.
governance. Can you talk about design time governance?
Design time governance, let's take for example, uh, I have developed some 100 services,
Okay.
I will just after deploying the 100 services, I will, but there are multiple teams working and everybody has developed their own services, but nobody knows who has developed what and what is available.
Yeah.
So right, so that's where governance comes into picture. We have
Correct.
registries and repositories, right?
Yeah.
Service registry and service repositories. So these tools are used to register the services. Okay,
Yeah.
and these services are mainly used at the design time. We can, when we are developing the services, we can reuse the services at the design time, and by invoking those APIs or those URLs. Okay, so and at the runtime, these are dynamically forwarded to the actual services that the service registries and will take care.
Okay.
But mainly at the design time, the repositories comes into picture. At the runtime, the registries comes into picture. Uh,
Very
Service
good.
registries.
So that this improves the reusability, right? Basically.
Yeah, reusability, the documentation, uh, and also the it gives a little bit of view of the service, what the service is, where is the service available, what it does, how to invoke that service. So
Mm,
it gives us the basic overview of the service
yeah.
from
Yeah.
the functionality perspective, from the consumption perspective. Uh,
Yeah. That's
it
good
gives all
actually.
those details.
So is it you follow kind of a wiki style documentation? Like is it a too traditional documentation, or you use some kind of blog type like developer portal kind of documentation, and all? Is it going to be
Uh,
very light touch documentation, right?
uh, it has when I talk about repositories, right? Repositories can have anything. It can have any Word documents. You can have a any documents. We can have it, and we can tag it as a particular service. And
Mm.
when we search for the service, we get all those documents. Uh,
Typically, what kind of documents you do basically in your experience?
okay, for a from the we are talking from development perspective, right?
Yeah, yeah, yeah.
Okay, from development perspective, okay, we will have a use case document, uh, the high level and technical design, and uh, then the release notes. Release notes means like for example, uh, it's kind of deployment
Deployment
document.
checklist and all that stuff.
Yeah, checklist, all that stuff. Yeah. These are the main documents, and the
Okay,
rest we can have based on our requirements.
very good, very good. That's very useful actually. Good, good. And I'm very glad that you're working in some of the latest tools, and I hope it's all cloud based, isn't it? Like MuleSoft in cloud, or it's all in-house hosted, I don't know.
Yeah, we have both. It's a hybrid.
Oh, hybrid.
I
Okay.
would say it's a hybrid architecture.
Right. My experience so far is with in-house. It's not hybrid, but I hope that it's not too much difference whether you do it in cloud or it in-house. So it comes its own advantages
Yeah,
and all that. That's good.
yeah,
And I think we are almost time, Raghu, and I want to thank you for joining and sharing your experiences and giving some insights on this. So much appreciated. Thank
thank
you
you.
again. And I hope we will see you in the next sessions also. Thank you.
Yeah, sure, Prem. I think I should thank you first for initiating the session.
Yeah. Much appreciated. Yeah. It's just again, as I was telling, this session is all about people like you coming in and sharing what you know and ask some interesting questions so that other people can actually come again, and it's a kind of debates and discussions. And let's see how this all takes us to. Yeah, thank you.
Yeah, thank you.
Bye. Have a good day for you. Bye.
Thank you.